Okay, we're in section 14 and we're doing the examples. I'm going to do the whiteboard. I'll do the examples. Again, after doing the examples, we're going to recommend that you try problems on your own. You have to study the examples we're giving you, including the lecture that we presented to you. Again, study is the most important thing you could be doing, and study does require you to do problems or homework. All right, so let's take a look. I'm going to the whiteboard now. And let's see if I can do that. And I'll walk you through each problem separately. So over here, I'm looking at it. It says find the instantaneous rate of change of the cube root of x. So the first thing I would do is I would write down what the function is. And the function, f of x, they say it's the cube root of x, right? What's cube root of x look like this over here? The next thing I'd probably do is write down that I'm going to have to differentiate this guy. And to differentiate this guy, I'm just going to put down that this is a power and it's x to the 1/3. So f prime, and again, this would all get credit in an exam if you get these steps right. So I wrote the function down what I read. Now I'm going to put the derivative down. And what's derivative going to be? 1/3 x to the -2/3. All right. Now, what do they say? They say, find the instantaneous rate of change of the cube root of x with respect to x. I want to point out really what this is the derivative of the function with respect to x. All right, I did that part. All right, now they want to do is evaluate that at, I'm not doing, we'll do it anyway. I realized I was doing something we've already done, but what's f prime of 8? What do you get over there? 1/3, 8 to the -2/3. I'm going to write a little differently. 1/3, that's going to be 1 over the cube root of 8 squared. You get 1 there. And what do you get next? Well, let's see. Cube root of 8 is 2. 2 squared is 4. 12. You get 1/12. All right. Sorry about that. I did something I shouldn't have done. We've already done it. And this is a problem. I'll be honest with you. When I do these problems, like I say, they always look the same to me. Okay, so let's say find the rate of change of the area of a square. So the first thing I would do, I know they're talking about a square. I'm going to say it says its side is S. I'll put this over. That's a cursive S, by the way. And the area of a square is actually a function of S. And what is that going to be? S squared. All right. So it says find the rate of change of the area of the square with respect to side. Well, that's going to be A prime. And what's that going to be? 2s. All right. And what's A prime? Well, they want to know A prime at 5. And what do you get over there? Well, 2 times 5 is 10. Pretty simple. All right. They didn't give me any units over here, so I'm not going to be worried about units in the problem. So again, we wrote down this. By the way, A prime of S is dA ds. And then we evaluate the derivative if I've got 10. All right. This one here, let's read it. And again, part of reading is understanding what the question is. So they say position of a particle moving in a straight line during the 5-second trip is this over here. Find the time t at which instantaneous velocity is equal to the average velocity of the entire trip. So, I got troubles here. And the troubles is, do I understand what I've read? So the trip here is going to be, 5 seconds. So the trip here, the time is going to be on the interval. And it says position of a particle straight line during a 5-second trip. So starting at 0 and going to 5. So what I want to do is I want to put down the average velocity because I did mention it. All right. Average velocity. And what's that going to be? ds dt. I should say delta s delta. I'm sorry. All right. And all this stuff gets partial credit. So what do I got to do? I got to do s. Let me do cursive s. At 5 minus s of 0 over 5 minus 0. Well, the bottom's super simple to do. The bottom is just 5. What do you got on top? Well, I got to do this over here. So let me write this down for you. What's s of 5? What's going to be 25 minus 5 plus 10, which can be 20 plus 10, which is 30. I'll write that down here. Minus s of 0. Let's write that down. What's s of 0? Well, it's going to be 0 minus 0 plus 10, which is 10. So what do you get over there? 20 minus 10. I'm sorry, 30 minus 10 is 20 over 5, so 4. All right. Now they're not giving, oh yeah, they're giving units over here. I'm sorry. So what are the units on it? It's centimeters per second. Now, by the way, someone says, was that their question? No, their question is find the time t. Well, if I'm going to find a time t, t has to be on that interval where the instantaneous velocity, what's that going to be? That's going to be s prime t. What's s prime at t? That's fairly simple. It's 2t minus 1. Now, they said where the instantaneous velocity is equal to the average velocity. So that's when 2t minus 1 equals 4. And they want to find the time t. Let me repeat this. The time t must be between 0 and 5. What do you get over here? 2t is equal to, I'm going to add 1 to both sides. That would be 5. So t would be 5 over 2 for 2.5. 2.5 what? Seconds. That was their question. That's the answer. And that's the work supporting that answer. Let's go next page, see how we did. And I'm seeing that work over here. And I'm seeing that answer over there. All right, this one over here, number 3. And again, I'm going to read it to you. It says a bullet is fired in the air vertically. What does that mean? Straight up. All right, from 2 meters above the ground. So, certainly ejecting a bullet into the atmosphere, it's going straight up. Certainly, I hope you realize what goes up must initially come back down. All right, so it says, initial velocity is 200 meters per second. Find the bullet's maximum velocity and maximum height. All right, so what I'm going to claim over here is looking at it. They have a footnote over there, and I want to point out the footnote. They give me something which you may be able to do on your own, but I'm not expecting it. What does it say? You may recognize this formula if you've taken high school level physics. Right? What kind of formula you give in high school? So let's write this down. ST is equal to 2 plus 200 t minus 9.8 t squared over 2. All right. And the 200, I want to point this out to you. That's the initial velocity of the problem. This 2 is its initial position, which is 2 meters above the earth. And this over here is gravity pulling that thing back down to earth. Right? It's having a big impact on the velocity of the bullet. The bullet's going to go up. I want to point out I'm firing a bullet. I'll kind of draw a picture of this thing over here. No, you don't have to draw a picture. This is the ground. I'll put the ground down for you. I'm going to say the bullet's here. It's being ejected up. I'm going to say it goes up. It slows down as it goes up, and then it stops. And then what happens to it? It comes back down to earth. It's going to hit right here. It hits the earth right there. Hits. So this is the earth. And by the way, if that's all you understand the problem, you know what? That's not a bad thing to understand the problem. The bullet goes up. It's 2 meters above the ground initially. Its initial velocity is 200 meters per second. When it comes up here, its velocity, I'm sorry about that. I didn't mean to put that down. Its velocity would be 0. Now, why is that? Well, that's when it stops moving up and then it comes back down. This is also going to be a place where you get maximum height. So let's see if we can do that. And what am I going to do? I'm going to look at the velocity function. So what's the velocity function going to be? It's a function of time. And it's just simply the derivative of s. So s prime. Well, let's put that down and see what happens. And then we'll talk about how we're going to use this. It would be 200 minus 9.8 t. Right, that's not so bad, right? So what we got to do, we got to figure out when the velocity is 0. So when, at what time t, is the velocity 0? I don't know. Let's put this down. The velocity is 0 when this thing becomes 0. Let's write this over here. 200 minus 9.8 t equals 0. All right. So what's the t going to be? Let's write this down. 200 equals 9.8 t. So t would equal 200 over 9.8. Now, what happens to a lot of students, they don't remember what the question is. But one of the questions, if you want to go back and read it, I'll read it up over here. One of the questions is the bullet's filed, vertically upward, initial velocity 200 meters per second. Find the bullet's maximum velocity and maximum height. Well, I'm ready to put the maximum height down. And why is that? The maximum height occurs here when the velocity is 0. How do I do the height? It's going to be S evaluated at that T. So I'll write that down for you. Now, if this is an exam question, I'm going to say what you should do is at least plug it in. I'll write this down for you. Or say put that over there. Minus 9.8 over 2 times 200 over 9.8 squared. And what is this? This is meters. On the exam, I'll accept this 100% as the maximum height. And write this down. This is the maximum height. All right. Now, certainly I want to claim, though, I really think you need to be able to start using a calculator to do computation. Make sure you can get that number over there using a calculator. Now, what I want to do is I want to talk about the maximum velocity. By the way, the velocity right here, the initial velocity is 200 meters per second, and it's moving up. The velocity there is 0. Then what does it do? It comes back down. The velocity at this position over here would be minus 200 meters per second. The velocity when it hits the ground is going to be the maximum velocity. Now, it may be negative, but it's a maximum velocity. So now comes my problem. When does it hit the ground? It hits the ground when S is equal to 0. Again, I know this is difficult. So it hits the ground when S of t equals 0. That's when it hits the ground. Let's see if we can figure that out. So what do you get? 2 plus 200t minus 9.8 t squared over 2 equals 0. Yes, I know for a lot of students, the arithmetic is going to kill them. But here's the deal. I'm going to multiply both sides by minus 2. I'll write that down for you. So I'm going to multiply both sides by minus 2. What do you get on the right side? 0. Then you get minus 4 minus 400 t plus 9.8 t squared. I'm going to write this down a little differently. 9.8 t squared minus 400 t minus 4 equals 0. Again, remember, this is an exam. I'm going to expect you to put work down, but any computations that are too difficult might require a calculator. You don't have to do it. So let's write down what t is. It's going to require a little thinking. Twice the a, right? I'm going to take the, let's see, twice the a, then opposite of b, plus or minus. It's going to be tough, right? The b squared minus 4 times a times a c, which is minus 4. So I'm going to put this over here. Now, what do I know? So I want to put this down for you. And again, I hope you can think without using a calculator at this point. This is going to be plus 400 squared plus 4 times 9.8 times 4 over 2 times 9.8, or t is equal to, the reason I write this down is I want you to think about it. Thinking is an important skill to acquire. Minus this thing over here. And by the way, we're not actually doing the arithmetic, but I want to point out over here, I hope you realize this is 400 minus, inside here is a number bigger than 400. So if I thought about that, bigger than 400 squared, this is definitely going to be a negative number. So this t is below 0, and that doesn't make any sense to me. So I'm going to cross this off. So this is the number we're looking at over here. So what am I going to do? I'm going to say the maximum velocity occurs V evaluated at this T. I'm going to put a circle here to communicate to a grader that this is the T I'm going to be using. This would be the maximum velocity. By the way, it's going to be a negative number. It is going down. Now, someone's going to say, could you compute that number? Yeah, and we want you to do that, but on an exam, you're not going to be doing that. So how would you do that? I want to point out it's going to be over here, and those numbers are computed for you. Again, I want to point out, the maximum velocity is a little bit faster than the speed of the initial speed of the bullet. So you notice it's minus 200. It is going downward, by the way. Now, here's the deal. I couldn't do that by hand. I really couldn't. Use a calculator. Make sure you get these numbers. If you're not getting these numbers on a calculator, come by during office hours and I'll help you. I'll help you learn how to use a calculator, including if it's Sage. All right, let's do number 4 now. And number 4 is a particle. I got to pull this on the side, by the way, because I'm running out of room. Oh, I made a mistake. Sorry about that. I did it again. Give me 1 second here. All right, let me get rid of everything else, all right? So much work over there. It's like a piece of paper that's never ends. I got to pull this on the side somewhere, so I get a lot of room. Not that you need a lot of room to do these problems, but thinking through them might be tough for a lot of students, all right? So what I'm going to do over here is I'm going to read it to you. It says a particle moving along a line is position ST. They say the T is greater than 0. I'll put this over here for you. So I know that T is greater than or equal to 0, which means the T is annual from 0 off to infinity. All right, I know about the T at this point. I know the position of the particle. Let me write this down for you. The position of the particle is going to be, let's see, T4 minus 8T squared. All right, I don't know the question yet, though, by the way. I know the position of the particle, and I know that time is greater than equal to 0. It says, what's the furthest distance to the left of the origin? What I'm going to do is I'm going to say that they're talking about a particle moving, all right? And it moves along a line. I'm going to say it's a line. And I'm going to say this is the origin over here. Now, what does that mean? It means S equals 0. All right, so what I'm going to do over here is I'm kind of curious, when does S equal 0? Well, I got to figure this out now. So what do you get? You get T squared, right? Comes out. What do you get over there? Did I copyright? Yeah, copyright. So it's going to be T squared minus 8. So clearly at T equals 0, that would equal 0. I'm sorry, I made another mistake. The other place it would be equal to 0 is at the root of 8. All right, so at 0, it's at the origin, and at T equals root 8, it's at the origin. So it's at the origin twice. So then the next question is, well, what is their question? Well, now they're talking about this thing moving around to the left and to the right. So what I would like to do is I would like to look at the velocity function now. So velocity. So how do I do that? Well, I know S of T, let me put the cursive S, is T4 minus 8T squared. So V is going to be the derivative of S prime. It looks pretty easy to do, by the way. And what's that going to be? Well, it's going to be 4T cubed minus 16T, right? So VT, that's a velocity function, is going to be 4T cubed minus 16T. Well, you know what? I want to discuss the velocity. And to do that, I'm going to look at what's called sign analysis, because I wonder how this object's moving. So I'm going to factor out 4T. And what would you get over there? Well, take a look. You would get T squared minus 4. So I know this velocity function, remember, T is greater or equal to 0. The velocity would be 0 at t equals 0 and at t equals 2, not -2, because -2 is not the story. So what I want to do is I want to talk about the motion of it. And what do I know? This is the velocity I'm looking at now. So I know it's on the interval, and we're talking about t now, at t equals 0. What's the velocity after 0? Well, let's take a look at it. You just plug it in. I'm going to go up to 2. T is 2. So between 0 and 2, what's the velocity equal to? I'll take a sample point, like 1. You learned this in Math 119, by the way. It's called sign analysis. That'd be negative. What does that mean? It's moving left. Now, after 2, what would it be? Well, take a number like 3, plug it in into the velocity function, and it'll be positive. So what I'm going to claim over here is that means it's moving to the right. So let me put this down over here. At t equals 0, what is it doing? It's moving this way to the left. And then what happens? When it hits the time t equals 2, it moves the other direction. And then it comes back over here. And over here, when it hits this over here, it would be √8 in time. And it keeps moving to the right. What was your question, though? How far did it get over here? How far did it get? Well, how do I do that? It's just fairly simple. All I have to do is evaluate S at 2. Let me go through that with you. So S at 2 is going to be 2 to the 4th minus 8 times 2 squared. Let's see if we can do that. 2 to the 4 is 2 times 2 is 4, 8, 16. This is going to be 8 times 4, which is 32. What does that give you? -16. Well, that makes sense. It's -16 on the number line, but how far is it? It's 16 units. Oh, by the way, the units here are in feet. I'm sorry about that. So it's 16 feet. All right, I think that's the end of the problems. Now, what I mean by that is that's the end of the problems I'm going to be doing. What does it mean for you? You got to do problems on your own. If you need additional support, though, I recommend you come by during office hours after you put the study time in. So put study time in. I know this is a tough set for a lot of students. One is it requires reading and understanding what you've read. All right. It also has some physical problems with things moving around, and that can be difficult for people, myself included, by the way. So bottom line, you need to get busy, study the material we present to you, and then do the examples. And hopefully when you're doing the examples, things are relatively simple for you. All right. It does take time and effort on your end to do well in this course, though. Thank you.